This is a question on similar plane figures. We have the figure ABC and DBE. If we look at it, we see that there are two triangles, one drawn inside the other. The larger triangle being ABC and the smaller triangle being DBE. Okay? Now, what do we know about similar plane figures? If we have two triangles, T1, T2. Let's call this side A, B, C, P, Q, R. This triangle, right angle triangle, right angle triangle. Two plane figures are said to be similar in mathematics if they have the same shape, irrespective of their sizes. Look at triangle T2, though it is larger, it is a right angle triangle. Look at triangle T1, though it is smaller, it is a right angle triangle. They all have the same shape. Therefore, T1 is similar to T2. If that is the case, then proportions of corresponding sides must be equal. What are corresponding sides? Okay, if you look at the side AC here, it is the hypotenuse here. It must correspond to the hypotenuse of T2. The side BC is the base of T1. It must correspond to the side QR of T2, which is the base of T2. And the side PQ, which is the altitude of T2, must correspond to the side AB, which is the altitude of T1. So proportions of corresponding sides must be equal for similar plane figures. So if we take, for example, here we see T1. Okay, we have said T1 is similar to T2, so let's start with T1. If we take AC is to BC, for example, you look, we have taken the hypotenuse is to the base, then we should come this way and also take the hypotenuse PR is to the base QR. Okay, if we take, for example, the altitude AB is to the hypotenuse, then we should also take the altitude here, PQ, is to the hypotenuse, PR. Okay? If we take the base, BC, is to the altitude, AB, then we should also take the base here, QR, is to the altitude, PQ, and so on. This is what we mean by proportions of corresponding sides must be equal for similar plane figures. With this background knowledge, we will now be able to find the length AC in this our diagram, knowing the dimensions of AD, BD, and DE. Okay? So, solution. Okay, so we see that triangle, the lateral triangle ABC is similar to triangle DBE. They are similar. Okay, and we know AD. We know BD. We know DE. Okay, so we know AD, BD. If you look at it very well, they stand for the altitude. Okay, if we make the symbol for the right angle triangle, then there's what we call the altitude. So we're still following that T. We call this one T1 and call this one T2. T1 is similar to T2. So let's take proportions of corresponding sides. We have all information concerning their altitude. So let's start with T1. The altitude of T1 is BD. BD is 2. Remember, we're asked to look for we are asked to look for AC. AC is the base of the larger triangle. So we have to take DE. DE must be equal to, alright, this is the altitude. So we're now go to T2. We take the altitude, which is AB, is to DB is the base here. The base here should be what? AC. AC. This is the proportion of corresponding sides that we need for this our exercise. If we look, we know BD, we know DE. AC is what we are looking for, but we don't know AB. What is AB? AB will be AD plus BD. Do we know AD? Yes. Do we know BD? Yes. Therefore, AB is 12 centimeters. AB is 12 centimeters. So if we take and put here, this now means BD 10 is to DE is 8, must be equal to AB. We just found it to be 12 is to AC, what we are looking for. We are looking for AC. So the only unknown is AC. We know the meaning of 10 is to 8. This simply means 10 all over 8 is equal to 12 all over AC. So from here, we can cross multiply. So that we have 10 AC is equal to 8 times 12. Okay? Now, let's take it over here. 10 AC is equal to 8 times 12. What then do we do to have AC? We divide both sides by 10. This 10 cancels, so we have AC will be equal to 2 here 4, 2 here 5. So we'll be equal to 48, 4 times 12, 48, all over 5, which will be equal to 48 divided by 5 is 9.6 centimeters. So the side AC in this our diagram is 9.6 centimeters.